Alright everyone, in this section we're going to talk about estimation. Estimation can be really helpful when you're working to solve some real-life math problems. You're not always going to know everything that you need to know. You're not always going to be able to predict everything that you need to predict. You're not always going to have exact values to work with. So, you need to use what you have to make some reasonable guess, and estimation will help you do that. It is a valuable skill when it comes to reading information from charts and graphs, and it's what we did in the last section. And we can practice this skill by just looking at some number lines. So we want to just estimate the values that are related to each one of these points. So here, point A, I'd say this is pretty close to 300. This is a span of 100, so we could call this probably about 290. In this case, negative 290. For B, we are a bit close to negative 200, but on the left of negative 200. So here, these are numbers that are smaller than negative 200. So this is about negative 220. Remember that more negative values are over here, positive values are over here. For C, we could say this is about equal to negative 140. It's not in the middle, but it's pretty close. For D, it's about, we could probably call that about 40, positive 40 in this case. E is pretty close to 100. We could say that's probably 105. And then F looks like it's between 200 and 300, so we could say that one's about 250. Even when you're estimating, you may not get the same answer as another person. Another person may estimate it slightly differently. The goal is that when you all estimate the same values, you get close to the same number. In addition to estimating numbers, it's also important to know whether one number is greater than, less than, or equal to a particular number. It may seem trivial in some cases, but numbers can take different forms. They can be positive or negative. They can appear as square roots. And so we need to know how to work with those. Remember from our number line, greater negative values are less than smaller negative values. So negative 10 is actually greater than negative 15. Positive values are always greater than negative values. So negative 100 is less than 50. And now the square root of 25 and 5, well, the square root of 25 is equal to 5. So these two are equal to each other. And so it's just important to know which is which. So let's try another one here. We have negative 23 and negative 27. Negative 27 is the greater negative number. It's more negative. And so it is less than negative 23. So negative 23 is greater than negative 27. Here, negative 11 thirds, well, if we rewrite this as a decimal, this is going to be negative 3.67. Negative 3.67 is more negative than negative 3, so it is less than negative 3. And finally, the square root of 64 is equal to 8, and we know that 8 is greater than 7.8. Now, if we know a list of perfect squares, we can estimate the values of square roots by just trying to get kind of close. So I'm going to write this out for you here. 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, 6 squared is equal to 36, 7 squared, 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Remember, when you square something, you're just multiplying it times itself. So 3 squared is the same thing as 3 times 3, which is 9. If we want to estimate a square root, we just want to look to the smallest perfect square to get a whole number estimate. And then we can do decimals from there using a calculator. So for example, the square root of 32, if we look for the greatest perfect square that's less than 32, we find that it's equal to 25. So this is going to be approximately equal to 5. Same is true for 51. The nearest perfect square that's less than 51 is 49, so this is approximately equal to 7. For 90, this is going to be approximately equal to 9. Now if we want to take this a little further, we can plug this into a calculator. The square root of 32, 5.66. The square root of 51, 7.14. And the square root of 90, 9.49. And so if we know the perfect squares, we can still approximate pretty closely to what those square roots are. Or we can just use a calculator to determine the square roots and round them to the nearest hundred. Finally, I'm going to show you how to find a square root in Excel. And so I'm just going to pause here real quick and switch over to Excel. And so here I just have a new Excel spreadsheet. In order to calculate anything in Excel, you want to click into a particular cell, and I'm just going to highlight this one here. Anytime you want to calculate something, you always want to start with an equals. To find the square root, we're going to use the function in Excel sqrt, and you'll see that it pops up here below it. And then if we open the parentheses, we want the square root of 47. Close the parentheses, and then hit enter. And we find the square root of 47 is 6.85565. We can do the same thing for the other square roots that we had in the previous example. The square root of 32, the square root of 51, and the square root of 90. Please let me know if you have any questions.